Hey crazy friends, check out the exercise we have here. We need to find the shaded area of the figure. Let's start. We have a quarter circle, a semicircle, and a circle. We need to find the radius of this circle to be able to determine its area. Around here, the center of this semicircle and the center of the circle we have here will appear. We are going to connect them with a line between these 2 points. Notice it will always pass through this point of tangency between the 2 figures. Excellent. Now the radius of this semicircle is half of its diameter. Its diameter is 16, therefore its radius from here to here is going to be 8. And from here to here will be the radius of the circle whose area we want to find, which we will call lowercase r. Very well. Now what we are going to do is draw a line from this vertex of the quarter circle to this point of tangency. We draw that line and it must pass through the center of the circle, like this. Very well. Well, from here to here, we know it's the radius of the circle in blue. And from here to there, how much will it be? Well, we know that from here to there is 16 because it's the radius of the quarter circle. Then from here to here, it must be 16 minus this little piece, which is r. Excellent, right? Now let's draw a line parallel to this line from this point to this point here, just like this. Great, and since it is parallel to this line, if there are 90 degrees here, there will also be 90 degrees here, and there will be 90 degrees over here as well. Very good. Very well, now we draw a line from this point to this point of tangency. Take a look. And here 90 degrees will be formed because we are connecting the radius to a line that is tangent to its perimeter. Since this line has a 90-degree angle with this line, and here too, then these 2 lines are parallel. If this is r, then this part from here to here, here it will also be r. And since from here to here it is 8, then from here to here it will be 8 minus r. Spectacular! We are going to call this line here x. Alright, now with everything labeled, let's solve this and find x. Pay close attention to this right triangle here. X is one of its sides. So using the mighty Pythagorean theorem, we know that one side will equal the square root of the hypotenuse squared minus the other side squared. Which side is it? It is x. So we have that x is equal to the square root of the hypotenuse squared. The hypotenuse squared is from here to here 8 plus from here to here r. So we have 8 plus r. And this squared minus side b, which is this one here. That's 8 minus r. So it's 8 minus r squared. Fascinating. And now we're going to solve these 2 binomials squared. We have that x is equal to the square root. The first term squared would be 64. Plus the double product of the first by the second 16r. And plus the square of the second term. So we have our squared. Very good. Now this binomial here minus, we open parentheses and solve. The first term squared 64 minus 16 times r. And plus r squared. Spectacular. And notice how this minus affects everything inside the parentheses. We can change the signs and remove the parentheses. So here we have a minus, here a plus, and here a minus. And now we can remove the parentheses and this sign here. Very well, all of this is under the square root. Remember, now look at this marvel. We have 64 here positive and 64 negative. We eliminate it. Here we have 16, r squared. And negative r squared cancel each other out. So we forget about that. And what do we have left? Well, x equals 16. r plus 16r, which gives us 32r. Phenomenal. We have the value of x here, which is this part. Now pay close attention to this other triangle over here. We also have 2 of its sides and we can find x again. So we're going to use the formula with x. X will be equal to the square root negative of the hypotenuse squared, and in this case, the hypotenuse is 16 minus r. Let's note this, and this squared minus the other side, which is r squared. Spectacular. Now let's resolve this binomial squared. We have x equals the square root of 16 squared, which is 256. Then we have the double product of the first term by the second, which gives us 32r, and plus the second term squared, which is r squared, and minus this r squared. And notice once again r squared cancels with r squared, leaving us with 256 minus 32r. Let's note that here, x is equal to the square root of 256 minus 32r. Phenomenal. And look at what we have here. Here we have what x is worth, and here too. So we can equate these two things. We can then say that 32 times the square root of 32r must be equal to the square root of 256 minus 32r. All of this within the square root, right? Or how do we eliminate the square root? We square both sides of the equation. We square on this side and on that side as well. The index cancels with the exponent and we have 32 times r as a result. Here the index and the exponent simplify, leaving us with 256 minus 32r. We continue here. So we move this negative 32 to the other side and we have 32r plus 32r. 32r, very good. And this is equal to 256. Isn't that amazing? 256, very good. If we add here, we get 64r, and this is equal to 256. We divide this, and we find that r is equal to 256. I don't know why I write the 5 first. 256 over 64. And when we divide, we get that r, ladies and gentlemen, boys and girls, r is equal to 4. That is the radius of our circle, whose area we wanted to find is 4. And with this, we can say that the shaded area is equal to p times the radius squared, because we are talking about a circle, right? And we are going to replace the value with 4. And by the beard of Archimedes, we can say that the shaded area is 16p, fantastic. And this is in square units, of course. Fascinating, we've already found the area of our circle. If you liked the video, don't forget to subscribe and give it a like. Bye-bye.